Okay, to include spikes, we already have the dispatch function assignments method calling level setup every time it finds one of these values inside of the map. Okay, so here in level setup for spikes, we're going to say if this dot values match 1250 e.tile value, that's going to be a spike. Okay, so a spike will have a canvas animation. Let's say spike any. Okay, this dot image is the source. Car layer is what it's going to get drawn to. In this case, we're gonna define from rectangle. Okay, kind of instead of actually animating it, we're just telling it where the first frame is. Well, okay, so it's going to be one and only frame. This is a spike right here. So that's at x of 800, y of 192, and it's 32 by 32. Okay, and we'll initially place it at e dot x and e dot y. Its width and height is going to be 32 by 32. Okay, so that's the spike animation. So we're not going to say define animation for the spike. What's going to happen is it's always going to use this rectangle as where to draw from. Okay, so the spike will move. So we'll say spike is going to be a map traveler. Its x location is e dot x and e dot y. Its width and height is 32 by 32. Okay. Its map current map. Okay, we're going to use the scene changer. Its animation is spike any. Actually, right now we're going to have to just say, we'll get to this in a minute, maps.level1. Okay, for its map, just for right now. Don't clone the map. This time it is going to clone. This one is delta time. The tile width is 16 by 16. Okay. And then similar to the player, since this is going to move around in the scene, you want to take away some things from its map. Okay. So let's just say spike.map again right here. And then don't draws. Okay, the property that we created earlier. Okay, so it'll take those values out of its map, similar to the player. And then now we want to push it into our spikes array. Spike. Okay, so now every time a coin spot or a spike spot is found in the maps during level setup, it's going to put a coin or a spike there ready to be used. Okay, so make sure I have all that correctly. One other thing we want to do for the spike is set its velocity up here. Velocity is underscore vloc. Just set it. It's not going to move vertically, just horizontally. So we'll set its velocity to math.random. Okay, so if math.random times 4 is greater than 2, then the spike's velocity will just be 4, moving it to the right. Otherwise, it'll be -4, moving it to the left. Okay, so just to randomly set the spike's initial velocity. Inside of our loop method, to move the spikes, we'll reset I to 0. We'll say for I is less than spikes.length, I plus plus. Here we'll have a spike property ready to use. Spike okay. So now let's make the spikes move. Now the spikes, we have the move method of travelers, and the basic ninja is extending a traveler. And there's also the update method. The update method just updates the position of it based on its velocity. Remove is actually also changing velocity. So for the spike, what we're doing is changing velocity ourselves manually. Okay? And so we won't use move, we'll use update for the spike to make it move. Okay, so right now the velocity is either -4 or 4, and if it hits something, we want it to change to the opposite velocity. So we say if spike dot underscore p right. Okay, and because it's a map traveler, it's automatically doing collision detection, and we can just check if it is p right, which means if it's pushing right. If it's hit something to its right, well then we're going to change its velocity to left. Its horizontal velocity x. Okay, if it's pushing left, well then we change it to right velocity. Okay, and then we say spike dot update, which is going to update its x and y property and some other things based on the velocity. Okay, so that's moving the spike left and right, and if it hits something, it's going to move in the opposite way. So now we want to display the spike using its canvas animation. We just say spike dot underscore canvas animation dot match position of the spike. So that's matching the animation to where it's moved to. And then we can just say spike dot canvas animation dot blit. Since we're just using it to show the one spike image and it doesn't really have an animation, right? So that's just going to cause it to copy from this rectangle part of the sprite sheet on to be displayed. Okay, and then okay, so now we should see all the spikes moving and the coins. Let's see what happens here. One thing with the Tabageos library, if there is some sort of major error, then the game will be offset to the left and not in the middle. That's one way to tell if there was an error or not. So there's not, we're good. There's the spikes, okay, except nothing happens when they hit you, but they're there moving back and forth. Okay, so now let's make some interaction when they hit the player. We want to know if the spike has hit the player. And we don't want this to be like coins. We want it to be a bit more precise than the coin test that we used, so that it's really just trying to, if you hit it, kind of give it some leeway too. Okay, so we're going to use the geometric math class again, but this time test for point in area. Okay. This dot player dot pos is generally what we want to test versus the spikes pos position. Okay, but the area, it wants the left top, right, and bottom rectangle for test for point and area. The left is the X position of the spike. The top is the Y. Okay, and the right is dot X plus the width. The width is 32, and the bottom is spike dot pos dot Y plus 32. Okay, so we're looking for this dot player dot pos within the boundaries of the spike. Spike dot X going left top, left top, right, and then bottom. Okay. So if that's true, the spike has hit the player, and we'll just reset the scene by saying this dot reset scene. Okay, and then we return out of this whole loop. Not just a for loop, but we return out of the loop because we reset the scene. With that, it should reset the scene when it hits a spike. Okay, it is resetting the scene. You can see that's why the spikes skip like that. But what it's not doing is resetting the position of the player. Okay, so when this method is called reset scene, scene position reset is also going to get called. Let's see if I put that. Position reset specifics. We define that it's going to be scene position reset. Okay, so whenever reset gets called, reset scene, this method is available too, because we need a few things to happen. Okay, we'll say this dot player dot set X back to its original X, which is 64, and this dot player dot set Y back to its original starting Y. That's going to set the X and Y and the position. That's why we're using set X. We could just say player dot X equals 64, but set X is going to set both the X and the position dot X. Okay, and then we also need to say this dot update and reset camera. Okay, so we hard reset the position of the player, and then so we need to also reset the position of the camera. Okay, so now when we hit a spike, it'll go back to the beginning of the level. Let's see here.